So in this video, I'm going to show you the first steps that you can take in learning Kubernetes. I wrote a blog post some time ago, so I'm going to walk you through that blog post and show you the steps that I have specified in that so that you can follow along with me on this. So let's get started. So before you dive into this, if you want a quick refresher on Docker and Kubernetes, I have similarly written two more blog posts on those subjects some time ago, and I have done a video on those as well. So I'll put all those links in the description section later on. Yeah, so let's get started. So in my previous video, as well as in this particular blog post, I talked about what is Kubernetes and what kind of problem that it addresses and so forth. So I highly recommend that you follow through this particular blog post and the video that I have linked here in the blog post as well. So to have your way started with Kubernetes, you need to have a Kubernetes cluster for you to do anything with that. So a Kubernetes cluster is a fleet of nodes where the pods concept, which is in Kubernetes, will get deployed, and the Kubernetes will manage those pods and so forth, that which we learned in the other blog post. But it's always useful to have some environment in your local machine so that you can do some quick testing. Although setting up a full-fledged production-ready Kubernetes cluster is a daunting task, where you will have to have multiple machines, and you need to be very conversant with the Linux platform as well as the networking concepts to do that. So we're not going to do that. Rather, what we are going to do is in this particular blog post, show you how to set up a test environment, which will be a single node Kubernetes cluster in your local machine. So there is this software called Minikube, which just enables that. It is a software that enables a single node cluster, which Minikube will be using one of the hypervisors that you have in your platform, such as VirtualBox or KVM or whatnot. That kind of a hypervisor will be used to spin up the Kubernetes cluster for you. So you don't need to worry about that. So you can just install Minikube by following through the Minikube getting started guide, the installation. So choose your relevant operating system and the architecture and the installer type that you want, and it's going to show you the steps that you want to take, you can take to install Minikube. So here you need to copy this particular command to download the Minikube, and then just install the Minikube version into the relevant directory in macOS. It's showing macOS because I'm running a macOS. If you happen to visit this web page in a relevant operating system, it will just select the relevant buttons here and follow along that. So I have already done that, so you should be having the Minikube already installed. So I have that installed, so I'll show you what I mean by that in a while. And then of course, as I said, so what Minikube does is basically just creates a Kubernetes cluster environment for you in your local machine, so that you can do your testing. To interact with that cluster, you also need another tool. So in the Kubernetes world, this tool is called kubectl or kubectl, which again you can install from the Kubernetes.io. So if you go there, you can download this particular relevant kubectl as well. I already have kubectl installed as well in my machine. So let's get started. So there are a number of other ways to do the kubectl installation as well, and if you had been following my previous video or the previous blog post, you could also go ahead and install what we call as Rancher Desktop, which will ship the Kubernetes environment for you with kubectl command line tool embedded within that as well. So if you have done that, then you don't need to install kubectl separately. So anyhow, I have kubectl and minikube installed, so I assume that you have it as well at some point, and then follow along. So let's see, if you have minikube installed, you should be able to run this minikube version command. So let me just go that, and then minikube version, it should show the minikube version, and that indicates that it's installed successfully. And if you have kubectl, you should be able to get the version of that as well. If you have these two similar output emitted for these commands, you're all good. So now I need to start the minikube environment, the local Kubernetes cluster. To do that, we can do minikube start. So this is going to start the Kubernetes is available, and some other details are provided here. You don't need to worry about it, and it's going to start everything. But in fact, in this case, the Kubernetes cluster or the environment is created not in virtual box or KVM as I mentioned previously. It's going to use Docker itself, and a particular operating system will be used based on that to mimic a particular Kubernetes node. Right, so that means it is started, and it says done. kubectl is now configured to use minikube cluster and so forth. You can also get the status of this minikube by running minikube status, and as it says, the host is running, kubelet is running, API server is running, and kubeconfig is configured and so forth. So if you are wondering about what is this kubelet, API server and host, I recommend again to go watch the previous video which I have linked in this below description as well. Okay, so now this is done. So we just did the minikube start, and we also did the minikube status. Also get the cluster information using the kubectl command, using this command that I have mentioned, kubectl cluster info. Let's run that and see. And also you can get the node information using kubectl get nodes. So let's run that. So kubectl cluster info, it's going to show you the cluster information. As you can see, the Kubernetes master is running, and Kubernetes DNS details are provided, and you can get more details as well. So now let's get the Kubernetes get nodes command, and as I said, its name is minikube, and there is only one particular node running, because we are not creating a multi-node Kubernetes cluster here. It's just a test environment, so it's just one single node. So we have that detail. Now next thing that we need to do is we have to find out the image of the container that we want to somehow package into Kubernetes environment. So Kubernetes has these concepts called deployments, replica sets, replication controllers, and so forth. So let's now create what we refer as a deployment using an image of a Docker image that I have. So I have a Docker image in the Docker Hub already, so under my name, and so this is the image name. So how you create this image, I also covered in my other blog post on getting started with Docker. Right, so we did this for Docker for beginners, and in that blog post at the end I actually showed you how to push an image to Docker Hub and so forth. So this exact same application is what I'm actually using here, and as you can see, so let's just copy this and create a deployment, Kubernetes deployment. And yeah, so when you do that, so it immediately returns, and let's go and get the deployments. You can get the deployments using Kubernetes get deployments, and you can also get the pods. As I mentioned in my previous blog post and the video, is that in Kubernetes environment you can't get the containers. What actually Kubernetes does is actually put this particular container into a concept called pod. So within a pod you can have a single container or multiple containers, but in this case, because we're just starting off, we are just putting one image there, so there'll only be a one container within that pod. So let's get the Kubernetes deployments using kubectl get deployments command. So I believe we should have one deployment named Flask REST API and ready status up to date and available, and it's been created 54 seconds ago. And we can also get the pods details using this. Again, there's a one single pod and which is ready and in the running state, and it's been created 67 seconds ago, and there has been no restart. So that's a useful information in case your pod's getting restarted multiple times. It's not a good sign, right? So you should check what went wrong, and the pod's name is this. Okay, so next thing is, now if you know what this particular image Docker image does is, it creates a container with a simple Flask REST API. So the REST API is exposed in port number 5000, which is exactly what I have done here. In most of these commands, it exposes the port 5000. So we need in Kubernetes world a similar thing as well. How do we access the port 5000 from the Kubernetes environment? So it can be done in what we call as a service in Kubernetes. Service is a concept that makes external entities call out any services that's running within the Kubernetes environment. So in this case, I'm going to expose this deployment as a service of type what we call as node port. So which means for that particular pod, a pod in Kubernetes will always have a particular IP address and a port. Another pod will have completely a separate IP address and a port. So what we say is, for entire deployment, which may have single pod or multiple pods, expose that as a single node, right? So which will, in our case, it will have a single IP address, or which is what the external people can look at and refer to forward anything to any pod that's been exposed as deployments, right? So that's a very good concept. So node port, so let's expose that. So as you can see, it is exposed. We can get the services using svc command, and as you can see, a node port is now created, and the cluster IP, which means the IP address of this node port will be this, and what we call as cluster IP is that this is the IP address that the cluster will know about. If you are sitting inside the Kubernetes cluster, you can call this particular IP address to call the service, but we are actually not. So in this terminal, I'm not actually sitting inside the Kubernetes cluster. I'm outside it. So I need an external IP address or some sort of a mapping for this internal port 5000 on this cluster IP to call from my terminal. To do that, in Minikube world, I can do kubectl port forward my service, which is running inside as port 5000. I'm going to expose that to the external world on port 7000, right? So that once we have that, and in fact it will have what it will do is, basically I can call it as a local machine, right? So now it says the port in the local machine, local loopback address 127001 is the loopback address. If I call port 7000, it will map or port forward that to the cluster's service, which is running on this particular IP address, right? And so because it is running now, I can't actually use this terminal, so I'll have to use another terminal to do that. So because it's a test environment. right? And I can now use this curl command. Now this is I'm going to call a resource in this REST API over here, and if it returns successfully, that means our cluster is up and running and healthy. So voila, it works, right? Okay, let's go back and let's also retrieve, also use this just for the completion. As you can see, we get all the products details. Okay, so now in the Kubernetes world, now we have this deployment, and one of the advantages of Kubernetes is that you can easily scale your pods, which is a daunting task if you are just running it in a local machine. This particular service, Kubernetes makes these DevOps tasks much easier. So let's to see that, let's first delete this service, right? And before that, I'm gonna stop the port forwarding step which we did here, and I'm gonna delete the service. You should not have that service anymore. As you can see, we don't have this node port anymore. And instead of creating a node port type service, I'm going to create a service of type load balancer. Why I'm trying to create this is because I'm going to scale the deployment to have multiple pods, right? Or in fact, what we call as multiple replication sets. In fact, it will be mapped to pods as well. And once you have those multiple pods, this load balancer type service will make sure the request will be forwarded to one of those three pods or one of those three services, right? So that you actually get the benefit of load balancing as well. So let's create a load balancer type service, and now you should have that load balancer type service as well here. Okay, so next thing I want to do is I want to show something called kubectl get rs. RS stands for replica sets. So what is a replica set? So let's first look at that. So you have one replica set. You have a name and desired, current and ready state. 7 minutes ago it's been started when we started this video. And there is only one replica set. So now what is a replica set? So this detail is already here. Replica set is a concept in Kubernetes to manage stable sets of pods. So when we started, we didn't specify how many pods or anything like that, so it just defaulted to one. So it will always make sure that one pod will be there. In case if you just delete that pod, Kubernetes will make sure that it always has one pod in the cluster. So this is the advantage of Kubernetes environment. And if you specify the Kubernetes that you always need to have 3 pods, and for some reason one pod disappears, Kubernetes will try to create a new pod immediately. And so basically this replication set concept is what is responsible for maintaining a given number of pods at all times in the Kubernetes cluster. So this was previously done in Kubernetes using this concept called replication controllers. So you can consider this replica set as an evolution of the replication controller. So instead of using the replication controller, you should by all means use replica sets instead of replication controllers. So in fact, what we created previously was not replica sets. We created a deployment which under the hood created a replica set as well. So deployments are a higher level concept. Replica sets are a bit lower level. So it's always good to deal with higher level stuff, because that's what is more desirable, and that's what is more understandable in general sense. So let's create 3 replica sets. So I'm gonna use this. We haven't deleted the deployment earlier, but for example, I'm going to show you deployments. it has only one deployment. Now I'm just specifying, I'm telling kubectl to scale my existing deployment to have 3 replicas of that. So if I do that, and now if I go to the deployments, it is saying 3 is up to date. Out of 3, only 1 is ready at the moment, 1 is available. You just keep on that. Now if you can see, out of 3, all 3 are available, and so forth. So now out of those things, so if you just go to the replica sets and pods, you should still have only one replica set, because we haven't created multiple replica sets as such. Replica set is a concept that makes sure that number of pods will always be available. So there's only one replica set that's managing 3 pods, and all 3 are ready. And if I just go to pods, you should be able to see all 3 of the pods are running here. And okay, so there's I would like to introduce another concept which is just available in Minikube, because it just makes the life a little bit easier. So you can run this Minikube tunnel command, which will make sure it creates a tunnel between your local machine and the Kubernetes cluster. So which means you can just access your Kubernetes service, the load balance service, which is exposing the service in port 5000. You can just access it in local loopback address instead of the cluster IP, because of the tunnel, right? So that's just available in the Minikube. So let's, before creating that, so I'll just go to SVC as well. Yeah, so now you have this, you can see this external IP is pending, and because it doesn't know how to do that, once you have this Minikube tunnel created, let's see, and then you can go to kubectl get SVC. You can see the tunnel. Because of the tunnel, the external IP is configured as the loopback address. So that I can now use this particular command. So what actually this resource does is, actually it's going to bring back the host name of the pod, right? So when we hit it, you should get different as you can see, the first 3 went to the same pod, but now it's a separate one. You just go again the same, now it's a different one. So 3 pods. Now you should only see one of the above. So you shouldn't see anything new here, because we just have 3 pods, as you can see. That's exactly what the load balancer type service is trying to do here. Okay, so we are done with the most of the work, and I just wanted to conclude this video by showing the Kubernetes dashboard that comes, and Minikube also has it. So if you just run Minikube add-ons list, you should be able to see the available add-ons in Minikube, so you can explore those, and I recommend you read through the documentation to see what other types of add-ons try to achieve. So I'm particularly interested on this dashboard add-on, which is already enabled, which is great. So now I just need to make sure that I start that particular add-on, so that I can access my dashboard here. So if I just do Minikube dashboard, and so this should automatically show a bunch of details about my Kubernetes cluster. And as you can see, I have 1 deployment, and there are 3 pods running. If you just click that, it just hovers over, like you see what's there, and there's only 1 replica set, and my image details are provided, where my deployment is created from. 3 pods, when it was created 14 minutes ago, and pod details and so forth. There has been 0 restarts, which is great, and replica set detail is also there. If you just go here, you can get more details about this as well. So in Kubernetes world, there are a lot of other stuff. Like you can create what we call as a daemon set, deployments, which we already have in this case, pods, replica sets, replication controllers. As I said, this is a bit of an older concept now, so that we don't have a replication controller. Instead, we only have a replica set. There's something called stateful sets, so we'll look at some of these maybe in another video. And so in service types, you have something called ingresses and normal services and so forth. In our case, what we just created was a load balancer type normal service, and there are other things like secrets, config maps, and storage classes available. So you can just click through these and see what Kubernetes has to provide to you. But in this particular tutorial, you won't find much of these information because we don't have any there. And okay, so that's basically it that I wanted to show. But as for the last step, I can just use Ctrl+C to stop the Minikube tunnel before I can delete the service and the deployment to make sure that everything is cleaned up properly. Okay, so let's do that here. So I'm going to use Ctrl+C, and then I'm going to remove the service. And now if you just go and check for the services, you should not be able to find Flask REST API, and yeah, it's not there. And if you just go to the deployments, you should still have it. So I'm going to delete the deployments, Flask REST API, and the deployment is now deleted, and you don't have it anymore. And if you just go look for pods, that should not be there as well. We deleted the service and the deployment as well. And as the last step, let's also stop the Minikube as well. So if you just go look at the pods again, you should not have anything. And okay, so let's start Minikube, so which is going to wrap up and clean up our Kubernetes cluster, which is our test environment in this case. So it's powering off the Minikube here, and all gone. And if you just finally look at the status, now it should say everything is stopped. Well, so that's all I wanted to cover here. Yeah, so if in case if you're wondering if there is a better way to specify the details of the cluster, like how many replica sets that you want, and other details about your cluster, yes, in normal circumstances you can provide a YAML or a JSON file to instruct the Kubernetes objects regarding the Kubernetes objects on what needs to be there in the cluster. For already, if you have a pod, you can get some of these details using this command as well. I'm not going to show it because I already stopped it. And yeah, so explore with Kubernetes further, and there are much more to learn on this as well. So I'll see you in more videos like this in future. Thanks for watching, and enjoy Kubernetesing. Thank you.